Testing. Apparently, I'm trying to remove Jeremy, hi. Apparently I'm trying to remove bit 1 from my bit mask where only bit 32 is set. Why would I do that? That's correct, right? Current bits is bit 32. Trying to remove 1, yeah. Well, we start with one element in each group, and this is these are the groups. So we have only A in this group, only B in this group, only C, etc. So I have 6 groups, each with one element. By the way, I represent my groups, my elements with bits, and the groups with bit masks. So this is 1, this is 2, 4, 8, 16 and 32. The original, sorry, the original thing is F E D C B E A. I mean, right? So PM groups looks perfectly okay. And there can be nothing wrong with this. It's trying to remove from group 0, which would be the first one. Oops, 32. But we cannot try to remove anything else than 32 itself, of course. So moved must be 32, and it is 1. That's wrong. Moved is returned from moved elements. think the moved element should just return. Oh, wait a minute. Yeah, I'm getting it. I have made a change apparently that broke my that broke algorithm 1. Sorry, that broke algorithm 0. That is really strange. Like a while ago this just totally worked. I split it up in multiple classes. It still worked. And then out of nowhere it starts to fail. Current element I begin. That is nonsensical to begin with. How is this going to the next element? That would be a good question. Increment. We're calling plus plus current element. I don't think I changed this function. Let's try to make that. Let's try to make sure that I did not change this. I could add an if condition, but I'm currently wondering why it broke. Well, it did work in the beginning. Plus, if I add an if condition to jump over the cases where the element just does not exist, then I would make it a little bit slower, I think. The whole idea was to use a single assembly instruction to jump to the next bit. I want to make sure that this code didn't change. I'm not sure if we can see that in git diff. You can try. Changed a load of the stuff. No, it did exist, thank God. So there was the old code, and it's not very clear, right? How about I just commit this and then go one commit back? I can stash it. Whoa. Whoa. Ah, no, that's too far back. That's way too far back. I did not commit often enough, that's pretty clear. Yeah, I could go to my backup, which I make daily, but I might well just look at the source code, I guess. Figure it out that way. Might not even be slow. Okay, so we have a bit mask. We have a group, and then inside that group we have elements. How do I find that? This is a single element. For example, if I call the pre-increment on mCurrent index, which is an element index, which is index of element type, which is bit set, which has an index type of bit set index, which has an operator somewhere here. That simply increments the index. That is not what I want at all. I'm really confused about how this came to be. I really want to look at the old code. This is what I want to do. Call next bit. What the hell? I made the changes like 2 days ago, for yesterday I mean. So I get a backup of 2 days ago, It might work. Damn it. Unfortunately, it's not that easy to get my backup back because I'm not sure how that works. I keep forgetting. Let's try to get it back in a directory here. Well, I keep forgetting that, as usual. Don't call it as a readme. Please tell me how to do this. .1.1.1.1. It's probably readable on the Unfortunately, this is not telling me how to get it back. List all archives on the repository. Borg list. That will do it. We need home Carlo. The last one is from hopefully at the top. Oh, that's 2020. My last backup from 2022. Okay, 1024. It's still making backups. Yay! Sometimes I find that it has stopped making backups. So we could look at the last backup. Now I always forget how to continue. Yeah, restore the Monday archive by extracting the files relative to current directory. That's what I want. So we'd have to do extract and then a path to the repo, but I think that's automatic. And then Monday. So we have Monday listed. It's maybe a bit too much, the whole home directory. That was also too much to ask. Okay, I'm going to try this. And then, well, what was it? Extract. And then I'm going to try a colon or something. and this has to work, right? That's not working. Archive path. Let's try that. No archive specified. Well, that was my archive. Just pausing everything. So maybe you have to pass the full path. Man, I don't know. We're very close, I feel it. But it wants something else. The Borg wants something else here. And I don't know how. I should add it to a readme as well. Maybe this is giving me a clue. Nope. Ew, it's empty. Why is that empty? Source this. This is this. Okay. Let's source this file. I have a bulk repo set, and then maybe it works with this environment variable set. Let's just try it. Nope. What the hell does this thing want? Well, Gigi, it's a sad day. Yep. We have a list here, and that worked out of the box, right? Yeah, I'll get everything. What if I do this thing that I just, whoops, where is it? Is that the path? Yeah, probably. This files in archive. 2 columns. I tried 1 column, it's 2 columns. Oh yeah, no, we can, yeah, stop it. Stop it, stop. I did not want to stop. But this is definitely how we do it. So now I go to extract, well, not here. Oh well, yes, exactly here, sorry. So how can I make a path longer than this? Exclude files. Find differences. Rename archive. There's no example for extracting a single file. Because we'll have to go back to just trying it out. I'm going to extract. No, let's stick at list until I have it. That's maybe a smart thing to do. Files came behind it, right? So I just have to start without a slash. And then we do Carlo projects /aicxx / partitions. There we are. That's a little bit much, so I can just go list just source. And that was already pretty, that is made this night, so I don't want to this one. So we want this one maybe. Well, the heck is still there. I want to go before the heck, I think. Let's try that one. Further back should not be necessary. Okay. Let's extract this. Extract. Then we go to let permission denied. Just make this root. Two days ago, finally. Now we have here element score, element pair, partition iterator. Here's my iterator. Maybe should test if it works. So it definitely looks the same as before. Yeah, not like that probably. Let's not overwrite my old one. Although I have a backup of that. Right here, right. So now we have a partitions 2. Let's make a backup of this one for quickly like, and then we move the old code to that place and I can recompile it. Nothing to work to do. Yeah, well, think again. No, I have work to do. Oh, that was a bit fast, but didn't want. That was very fast. Let's make a change. Okay, definitely compile it. This works, but we started here with everything, all the elements in one group. So let's go back to having a single element in each group, if that is possible. What? I named it back. Oh, did not crash. So this begins with moving A. It moves, yeah, that's correct. So it has to move A, that A is the first element, and then it moves into the first group. This is the first group, second group, etc. So it moves the first element A into the first group, then you get AP. And it moves the first element into the second group, and so on. You see all the A's here being put in the next group, and then we start moving B, and so on. So this works. Well, it stopped working here. I have to admit. What the hell is going on here? We lost A completely. The sort is missing. Let me add a sort back as well. The sort is done directly after construction, but more importantly in operator star. Okay, I can do that, I guess. I do not have another constructor here. So we go to the operator star. Calling p sort. I do have a sort, right? Do not even have a sort. Have to add sort as well then. Oops. Seriously, this thing is still called M elements? Or did I add it to some... I should have added it to something else. Oops. Partition. Partition also has a score. I thought I put the sort after the score, but I put it in the wrong class. Doesn't know sort, which is probably algorithm or something. Algorithm. Yeah, you cannot sort without the operator less than. So now you have to add an operator less than. For for group. I'm going to add it back first because I have to copy it from there. Sorting. Sorting with the groups. Probably go to group. That was partition. Here we have group. So fix the bug. Yeah. So now you see first it does A, and then it does B, and then it does C. So long story short, this version still works. And now I want to understand why the other one broke. We do that by looking at operator plus. For a start, this is a partition iterator. Next, partition iterator in. Okay, so the partition iterator is a member of partition iterator. What? Operator plus plus is a member of partition iterator. And this one worked. Also a member of partition operator, I hope. Yep, quite obviously. And they both returned this pointer. But this one calls increment on the base class. There's two of them. Well, we're talking about the single element one, so that would be this one. And then that should be equal to this. So this is the working code. Let's just copy that. And then compare that with code that we have. Okay, so this is the working code. And then the working code, the new group was still called new group. And later I renamed it to to group. Well, it really should be the same thing. So now we get if to group equals element is alone, groups of original -1, groups of original is a +1. To groups set to 0, equals end, and index group set to undefined, break. Original was apparently renamed to original partition. I can also do that. Original was renamed to original partition. And current element group was renamed to from group. So absolutely no change. Yeah? This function is still correct then. Well, one of the big differences, well, the problem rather is, I think, at least the starting value. I'm so not understanding this ++ here. Alternative chill. Thank you, man. Okay, I guess we can delete this because it's exact equivalent. Well, what else can it be? Okay, so what we are doing here is this just calculates the scores. Even the very first one goes wrong. So here we get the partition iterator that is set to the begin of the partition. No game. What the hell? Dude. No I, please. There we are. So this calls a certain constructor of partition iterator, and the old code also. And that constructor is this constructor. Keep typing the wrong thing. This constructor. Yeah. That's funny. I'm in this file and I jump to the partition iterator and I get to the other file. Should not do that. It was confusing. And we get here and then that's what is missing. This one is initialized with group of the current element index. Pretty sure that is missing. I think, at least. So let's try figuring that out. This is not the file I want to be in. Next. This is the file I want to be in. We call this, we pass a unique pointer to a just created algorithm, which gets us here. And the algorithm thing is this one. And it does call group of. Calls partition iterator base with the group of the current element index. Partition iterator, no. It's doing this weird thing again. I think it's time for the debugger. Well, this is not interesting. Just generating stuff. So the first algorithm is, and now I get here, now I create something. Yeah, let's just try to figure out where it exactly goes wrong. Could set a breakpoint on 748. I think that's already wrong then. Yeah, continue. That looks good. Group is 5. Now I'm confused. What? Hmm. Seven, 4, 8. That's the breakpoint that I just deleted. Okay, how many continues? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 20. Now we are already there. Continue. 20, 21, 22. So we can continue 21 times. And then it goes wrong. No, it doesn't. How funny is that? Two, 23, 24, 25, 26. Now I can continue 25 times. Continue 26. It reproduces. So this is current element is A, which is not in group 0. So yeah, it's already wrong here. Of course it's already wrong, because if now I do next, then it crashes. Yep. So even next is crashes already. I have to do it one last time. Continue 24. Now it still seems to make sense here. You have index is 5, which is the 6th or the last element, which is F, which is bit, well, it's 2 to the power of 5, 2, 4, 8, 16, 32, which happens to be element number 0, aka form group 0. This is correct. Now we're going to do ++ neighboring partition iterator, and then I think it is incorrect. Yep. So it goes wrong in this ++ iterator here. Try run again. Yes, continue 24, next, step, have to wait through this get. Well, funny enough, that is the code that I looked at, which before worked. This was equivalent to the old code, and now it's going to corrupt my thing. Why? How is that possible? This should be true. Yep. The number of groups, well, that was 6. So we're going to say compare with 5, and the 2 group is currently 4. So after increment it is 5, which is equal to 5. Therefore we have reached the end of the number of groups. And do I understand this? What is the current? This value is simply already that thing. Yeah, okay, end up with this. You see, the number of groups of the original is 6. The original is simply 1 element in each group. I want to move from group 0, which contains 32, and we want to move 2 to the power 5 is 32. Well, that's correct, but we already did that. Now we want to do And this is my iterator, and we want to do operator plus plus, so we want to go to the next iteration. And the first thing it tries is to increment the to group. The to group is currently to group is 4. That would be the index of this thing. So that is 0, 1, 2, 3, 4. So you would say it just simply goes to the next group. But that group is now empty because it's our from group and the element was alone. So after removing this element, the group is empty. Plus I wouldn't want to move it into the same group to begin with. So we are kind of at the end of the move to groups. So what I do next here, we should end up on line 516. Okay. Now then it says okay, then the to group was at the end, it will begin at 0 again. So now we're going to move to group 0 again. But then we also have to increment the element that we are going to move, which would mean that this becomes 6, but that of course that's also not possible because that would refer to 2 to the power 6 is 64 and the highest value is 32. So we are completely at the end. So this is set to 0 at first, and then we find out that if we increment element index, which is currently 5, we get our end, which would be 6. So if we do next here, we should end up on line 519. And that is the case. And then we want to set our iterator to the end iterator, which apparently uses current element index 0 and group undefined. I see it coming now. It is the unequal operator that is wrong. So we do this, we break. I'm gonna do step even. Yep. So now this thing has become the AND operator. Let's try to find where I printed the thing. Yeah. It is the AND operator because the to group equals -1. We're going to compare that with the current partition end. Which is the AND operator because base is equal to 0. Let's just do step here. I wish there was a step until I get into my own code again. Where are we now? We're back here. Now I want to go to, there we are, operator unequal. This says if both have a base pointer, and they don't, because my AND operator, that's the right hand side, does not have a base. Right, the other one does have a base, but that's a base that points to some AND iterator. But at least they do not both have a base, therefore we continue here. Now the right hand side does not have a base, so this is true. So this becomes true, and this should also become true, and therefore the unequal operator should return false, and therefore we should exit the for loop, but that doesn't happen. So apparently this is going to return false. Well, base was set, so this is false. And then if that becomes false, apparently this is going to return false, while it should return true, because the to group is undefined. So I want to step into the isEnd. Next step. Now I'm inside a bool operator. Inside get. Now I'm going to step inside is first the pointer, and now I get a get again. Very tiresome. Clearly the GDB maintainer never uses C++ because it keeps being unusable for reasons like this. Finally we are in isEnd, and it checks just the from group and not the to group. So this is the bug. If we tested M2 group, it would work. Now the reason I only test the from group to be undefined here is because I expected that both to be undefined, to the to group and the from group. And I think I should stick with that, so rather the problem is that I did not set the from group to undefined. Oops, not move. So let's that is in operator plus plus of the single no increment. It is an increment of this partition iterator single element, and then when we get to undefined here, we also have to set the from group. That's the correct way to make it an AND operator. I also did that in the other case here, and then we do from first and to afterwards. Let's stick to that here as well. Not even sure if this is necessary still then, because I don't think I'll look at that. I will remove that. So this is the way to set it to undefined. Now that would be code duplication, and as we all saw, it went wrong because in one case it worked, in the other case it didn't, and that is because we had code duplication and I wrote something that etc. No code duplication is better. So I'm going to replace these two lines with a function call. Set to end. It's in the name. And then the other one as well. but this then has to be a member of the base class, so we can both access it. You see that this was the right decision, because now we have these functions together. Set to end does this, and is end does checks just F4 group. I might as well just remove this now. I mean, you see, it's just only checking M4 group. How disappointing. It did move now C into D and then crashed. Hopefully it's a different bug. Using less than together with and is suspicious. Very suspicious. It depends a bit on what IND is. Okay, IND is simply something with the value s IND, which is a number of elements, so that should work. Well, let's run it in the debugger again. Yeah, index equals 6, so that is equal to IND. I think I should do index must be unequal IND, because usually you never ever want to get past it and you only increment it by 1. And the increment, so I mean you call the increment operator on it, and then the increment operator should never go past the IND, whatever that is. So it either is equal to IND or it is less than IND between quotes. So comparing it as less than is kind of strange. Now in this case we are talking about indices, so really, yeah, I mean it is literally wrap around an integer. That's why it works, but I don't know. Anyway, it works. Therefore, y is index equal to end, and we get here. You cannot convert an index to a bit. At least that would not make any sense. So we do up. Apparently we're trying to construct an element from an index past the end. Well, such an element does not exist, so the assert is correct. We should not try to create an element from an element index that points past the end. Yeah, so we should not try to check if a non-existing element is alone. Why is mCurrent index end here? Well, I mean, I don't care, but I think the reason that this suddenly starts to fail is because I removed resetting this thing to the begin value. Until before it would perform this on 0 instead of on 6, but it still doesn't make any sense, of course. Create a begin iterator. Current element. Yeah, so then this. See, the from group is -1, which means that we are talking about the end iterator. And you can call this undefined. Previously I set it to 0, but it doesn't even matter. Create a begin iterator. I mean, who did initialize that? It would be initialized inside the class itself, or not at all. If it's not at all, it's undefined. If it's undefined, then oops, what are I trying to do here? This is really weird. Standard make unique. Yeah, I think we have access to uninitialized memory then. Which means that if we run it in vulkan, it should tell me that, right? Conditional jump or move depends on uninitialized values. Index to bit. So indeed it's an undefined value. Still going one back. Unique pointer. Yeah, we're just creating a. So for some reason I'm calling begin, and then we call this constructor. Why would it do it like this? Why not just simply I mean, it's the return type, so you might as well just pass it like that. It's going to construct it from these arguments. And that creates, this creates algorithm, which happens to be, I think still this one. And that uses mCurrent element index, which was not initialized. It says, well, it should have been. Why would I expect this to be equal to element I begin if I don't mention it? Okay, this is confusing the hell out of me. What? Well, that would be pretty shocking. Element I begin is just a static function that returns 0. It returns as I begin, which returns index begin, which happens to be 0. Therefore, I would expect that if I do not mention the thing, this thing here, in the initializer list, that it gets initialized like that. If that's not the case, then I'm very, very shocked. Very shocked. Oh, thank God, I see it. It is true, but it initializes things in order. This is the base class. So what it does, I do not mention this thing in the initializer list, which means that the compiler inserts it here after the base class. So it's this is the actual constructor. So if I pass the thing to the base class, it has not been initialized yet. Well, that was a strange pitfall. Now group of takes an element as argument. Group of takes an element as argument, yeah. And I begin returns an element index. But I can convert without that there has an explicit. An element index can be converted to an element with this constructor here. So the compiler should take care of that. Let's try to compile this one. I'm gonna write Valgrind, no errors. So now we get the following: algorithm 1 arrives at a solution, and then algorithm 1 cannot improve on it. And then algorithm 0 cannot improve it, of course, and then algorithm 1 cannot improve it, and then finally it stops. So that is slightly less efficient than it could have been. It could have stopped immediately after this one. Algorithm 0 is not going to stop until it cannot improve on it anymore. Therefore, if the next algorithm cannot improve on it anymore, we are done. No reason to try again. Can I improve that? First of all, I want to start with I'll swap the two algorithms. Start with the whole group thing. So given an algorithm, we do this until that algorithm cannot improve upon it anymore. Then we get here. Then we run the next algorithm, and if that then also cannot improve on it, then we're done. So in the case of having only two algorithms, yeah, so the last score 2 is a wrong approach. I'll continue running this loop until there is no improvement anymore. So until not have improvement. Let's not hardcode a constant. So I want to count the number of algorithms that fail to improve it. And how are we going to do that? I guess just here. Algorithm count. Yeah, it's a bit fake. Let's remove that. So we have a no improvement count. No, I'm going to set this to 1, anticipating that the first algorithm is going to fail. So we run this algorithm, and then suppose it fails to increment it, then we are done. No, that's also not correct. It runs, well, the point is it runs until it cannot improve it anymore. So at this point the value equals 1, and if then maybe it should just increment it here. see. In this case, we did improve it. So what have I set it to 1 here? Anticipating that we are going to continue running until we did not find an improvement anymore. So if there were previous algorithms that failed, then directly after this while returns the no improvement count equals 1 for this algorithm and not for any previous algorithms. And then we go to the top. I could anticipate that that algorithm is also going to fail. So we could now start at 0. So for the first algorithm we start with nothing failed, but I anticipate that this one is going to run till the end without improving it. If it does improve it, we set it to 1, which it already was. It's kind of a reset then. I think this works. And then not have improvement means that the no improvement count equals the number of algorithms. Duh. Do I have to set it to 0 here or not? I mean, at the moment we go to the top, we can just remember the value, right? I think I can remember the value. Yeah, definitely. All this trouble and still no improvement. What the hell? Cordis, I completely agree with you. You can only learn programming by programming. And then, okay, if you try to program something and you just don't know how to do it, then you have to look up how to do it. But then you still you didn't learn anything until you then use what you read in a program. Okay, now all those people that want to learn to code, help me with this. How can I make this for double loop stop as soon as number of algorithms fail to improve it on a row? So this is the first loop, the second loop, the third loop and the fourth loop. But this loop is simply running over all neighboring partitions, trying to find one that has an improvement. If it finds one, then it's actually Yeah, if it found an improvement, it's going to run the same algorithm again. Let me add some comments in here. Run algorithm. If algorithm found an improvement, run the same algorithm again. So if we did not find an improvement, then the number of algorithms that did not find an improvement is at least 1. If the previous algorithm, before this algorithm, did not find I don't like this plus here, but okay, if the previous algorithm did not find it, then at this point no improvement count should be 1. And then we should increment it before we get here, so we do that here. So this is more like anticipate that the current algorithm so it's more like if at this point here the previous algorithm did not find an improvement, then the improvement count should be 1. Yes, some Dutch. And then we anticipate that the next algorithm also will fail, so we set a no improvement count to 2. And then assume that this is never true, so it did indeed not find an improvement. Then we did not set it to 1 again, therefore it's still going to be 2 when we leave this. And then the no improvement count equals the number of algorithms, which is set to 2. Therefore we break out of this loop. And now we found the bug. This must be unequal or less than. The stupidity of it all. So it was more or less correct, but I just had this one totally wrong. So when it is equal, we just break out of it, and therefore also break out of it, we just completely leave the whole function. Program even. The program has finished. Now imagine that algorithm 0 could improve on it, and then algorithm 1 failed. So if algorithm 0 could improve on it, then it did set this to 1. Therefore we do not break, and we go back to the top here. And then it's incremented by 1, now it's equal to 2. Anticipating that algorithm 1 is going to fail. And if that's the case, Now we don't do this, and therefore, well, we have to we stop. And if it does, this just has to work. Now it works. Right, so algorithm 0 runs until we have the solution, and algorithm 1 cannot improve on it, therefore we stop. Okay, well, that looks nice. I guess I still should make a brute force one to be 100% sure what the best solution is, so I can know if we found it. This was just hard-coded stuff. Oops. It doesn't look like it changed anything. I'm using a constant seed. Why am I doing that? That's scary. That's scary because I'm pretty damn sure that I added code at some point, right? We use a variable seed. Huh? Where did that code go? Am I completely nuts? So strange. Possible. I know 100% sure that I added it. Oh, actually, I think I know where it went. That's part of hack. Did not add it to partitions. Wait, of course I already have random. No changes. Okay, now I want an example where the last algorithm. Okay, this where finally works. Okay. So now this algorithm got stuck on 111, but then the next algorithm was able to fix it. I'm going to flood the chat with repetitions of the same phrase. Has Nightbot gone completely crazy? Because this is like the second time I see that it does that. I allow people to repeat things 45 times, and it kicks people out after one. I think Nightbot is 100% broken. Oh, 12 emotes should be enough. Now we have the blacklist, and that is also not working anymore. I might as well kick Nightbot off my channel. It's just not working. We need a better thing. I need a better bot. Well, 5 seconds already passed, and I can also not override Nightbot. I cannot tell it, you know, whatever it does, and undo it. Also doesn't work. What a shitty bot. What am I looking at here? Back bork. Okay. Well, this is all nice and dandy, but I want to know if it is optimal. So I need a brute force algorithm to know if it is the best solution. Nope, never did anything in Unity. You know, it's also pretty frustrating. The only article that I found about possibly my problem here that I'm trying to solve, a cutting plane algorithm for a clustering problem. So I happily started reading this. I think I got till I got till here, and then I got tired of it. I would really understand everything. Well, it is understandable, but it's hard to remember for me. Like I was reading this, and then already had forgotten again what this notation was. Well, basically, Torres Han asked, did you read any research about the problem? Yes, that's this. It's the only thing I could find. At least I learned some keywords now. Apparently, in a graph theory, a clique, C-L-I-Q-U-E, is a subgraph that is complete. So this is a graph. Each element is a node, and these groups are cliques, aka complete subgraphs. That is, there is an edge between every element, every node, element, vertex, all the same thing. So we have EF, EK, EM, EO, FK, FM, FO, KM, KO, and MO. So between every pair there is an edge, and that edge has a weight, and the weight is given here. For example, I said we have FM, one of the pairs. Then you see here that FM has a value of -1. So this is the weight of the vertex between F and M, which appears in this clique. While we do not have a vertex between A and P, because they are on different cliques. There are no vertices between the cliques. So this is a complete graph, this is a complete subgraph, this is a complete subgraph, this is a complete subgraph, and this vertex has no edges connected at all. It's just a single vertex. There are no edges between these things. And then you can read this as follows. I didn't want to do this first because I thought I might chase everyone away, but on the other hand, it's just a few Greek letters, and essentially it's not that hard to understand. I'll read it and then I'll explain what I make of it in terms of my program. So we assume that the reader is familiar with basic concepts of graph theory. Well, that I don't know if people know what a graph is, but a graph exists of nodes, and then we draw lines between nodes. Okay, so in this case I think that my problem is related to a graph because I want to assign a value to each pair, and an edge between two nodes is exactly a pair. It defines a pair, namely the endpoint, the begin node and the end node of the edge. So an edge is a line between two nodes or two vertices. It's the same thing, and I call them in my program elements. And that line or edge is then a representation of that pair, and edges can have weights, which is then these values here, right? So these are my vertexes or nodes or elements, and I have them twice, and then for each different one, I mean there's nothing on AA or BB here or CC. No, we only talk about undirected edges. So also this whole triangle is empty because it doesn't matter if we have GA or AG. So I only talk about AG or GA is just given here. So that's the basic concepts, I guess. The definition is not given here, can be found in all graphs we consider as simple. I don't know what that is, but probably good for us. We denote a graph G with a node set V and an edge set E. So of course you cannot just talk about all the nodes, which they call V. All the nodes are these. It's just a list of all the nodes. So this is my V. But you can also talk explicitly about all the edges that appear. So in order to talk about an edge, you have to give the begin and end point. to, especially in this program, I had that. So each of these things is an edge, because they name 2 endpoints. Where A through F are my vertices or nodes, and then BF is the edge between B and F. Now you will not find FB, because BF and FB are the same thing, and I just put them in alphabetical order, so I could not get confused. These are all the edges that I have. So this collection here is, this whole collection here is there's 15 of them, and they are the set E of all edges. And I write a group. It can be expressed as from the set of vertices and the set of edges. Then you have the whole graph defined. It's kind of logical. An edge E with end nodes U and V is denoted by UV. Yeah, I did that too. This is my edge, denoted by the 2 elements. If S is a node set, I guess S of set, of GVE, so that's a number of nodes, then we denote the set of edges in G with both end nodes in S by ES. That is, that ES is defined as all the edges, element of all possible edges to begin with both the begin point and the end point in S. That was fluting. Now we don't speak Russian. So really nothing special here. This is maybe looks scary, but it just means that if you have a set of vertices, then ES means all the edges that are completely within S. Moreover, if S1 to K are subsets of V, then, and now we do the same thing but then with multiple arguments, is the union of all the ESIs. So you have subsets, multiple subsets, then of nodes, then all the edges within one of them, and plus all the edges within the other one, and so on. All added together is denoted like this. So we can compare that with this. For example, if this is our graph here, then this could be S1 and S2 and S3, and then all the edges inside of each is just all the edges that you can make, all the pairs that you can make, because our subsets are cliques, aka complete subgraphs, aka CI exists and CP and IP, and here EK, EM, EO, KM, KO and MO. So this defines 6 edges, and this defines 6 edges, and this defines 3 edges. And then if you write down S, this comma this comma this, then you have all the edges together, all the edges in this plus all the edges in this plus all the edges in this. It's just a way of notating stuff, I guess. If S and T are a subset of V, and the intersection between S and T is empty, and that's definitely always the case in our case. But there's no intersection, right? I mean, it's not that there is an A in here and the A is also in here. It's not allowed. All our cliques are one complete, and two, they are completely separate. Then they have a new notation, namely square brackets with a colon in between. Means all the edges with one endpoint in S and the other endpoint in T. Well, those edges do not exist, or they have a weight of 0 in our case. A graph is called complete if every pair of its nodes is linked by an edge. A clique is a subgraph of a graph that is complete. Well, I already said that. A clique is not necessarily a maximal complete subgraph. I don't know what maximal is. I mean, if you ask me, when it is complete, you have every edge that is possible in it. So how can you possibly make that even bigger? I would say that maybe maximal means that that the clique is the whole graph. That it just contains everything. But okay, we will denote the up to isomorphic unique complete graph with n nodes by kn by vn en. So instead of g, they use k, and then index n means the number of nodes in it, and that would be then this sub thing. For example, this would be a K4, this is a K4, and this is a K4, and this is a K2, and a K1, etc. But we have multiple K4s here, so you might have to write down the vertices that actually go into it. We say that gamma is a set of W1 to K is a partition of V if the intersection between every W is empty. For I and j between 1 and k, but unequal and I less than j, which means that it's unordered. V is the union between all of them, and Wi is not empty for all I. So that's again simply what I do here. So this is W1, W2, W3, W4, W5, W6, W7, and there is no W8 because then that would be an empty one. And as you can see, the intersection between all of them is empty in our case. There's never an element in both of them. And the union of that is V. So we use all the elements. So if you do the union between all of them, then you get all the elements that are in this was V, right? You get A to P. So this this gamma is exactly one of the partitions that I work with. And it is a way to partition all the elements that I have. And then gamma is one of them. Where was I? Here. I'm not sure why they order I and j. I mean, if this is true for wi intersection with wj, then of course it's also true if you swap I and j. But maybe it's handy somewhere. It's at least it distinguishes I and j. Okay, a set A of edges in a graph is called a click partitioning of G if there is a partition, comma, of V such that A is, and now they reuse this notation. I hope you have the same thing as me, that I forgot again what this meant. It was the union of all edges in each of these things, and those things were all the edges within it. Okay, so we have a lot of W's and then all the edges in each W, and then the union thereof. Okay, so this is just all the edges. A is all the edges that I want to sum up. And so we have a given partition. Then within one group, we have a lot of pairs. So I counted them before. I've got it again. 3 plus 2 plus 1. We have 6 edges in this one. aka 6 pairs, and we want to add all the numbers that are given here of those 6 pairs. We want to add them up and also add all the numbers, all the weights of the edges or pairs in this clique or group, and again for that one, and again for that one, again for that one, etc. So A is exactly that. That is the union of all the edges that we see in each of these W's. So these are the W's. The edges are given the 6 edges here, 6 edges here, etc. And then if you do the union of all those edges, you get exactly what I have to sum up in order to get my score. So A are the edges that we want to sum up, and it's called a clique partitioning of G if there exists a gamma of subsets such cliques, basically, that W is a clique. Okay. Note that every clique partitioning A induces a unique partition. Okay, note that every clique partitioning A induces a unique partitioning of W's of V such that A equals E that. Yeah, okay, well, isn't that kind of trivial? They turn it around. They say if you have a lot of edges that fulfill that, then you can also find back the cliques. In case G is complete, every partition of the node set of G induces a clique partitioning. In our case, G is complete in the sense that I do have defined a possible weight for every pair. So in our case, it's true that every partitioning that we can think of creates a clique partitioning. Now they talk about something that I was thinking like, what? And I scrolled a bit down, and later I saw that they found that their program was never using it, so they dropped it altogether. So I don't think that it's really interesting to understand this notation, but nevertheless they work with a cycle C, which is a subset of E of length K, is an edge set of the form v1, v2, so that's an edge, and then v2, v3, which is of course also an edge, but apparently starting where the other one left off, and so in until you got to vk, and then we go from vk back to v1, so we have the edge v1, vk. So that's a loop of edges, a cycle, which obviously has to exist within a W. In my program I use them, I call them groups, we can call them cliques, we can call them subgraphs, we can call them subsets, and now we can call them W. One of the very confusing things, I think, sometimes, this kind of thing. So you get a lot of names that are basically meaning the same thing. I try to avoid that in my program. I really try to always use the exact same name for something that is the same thing. So what a cycle is also kind of obvious, I think. And obviously for every different I and j, the vertex must be different. Seems trivial. And then for k equal or larger than 4, the set C with a bar above it is defined as, this means is defined as, the set of edges vi plus 2. So we skip every time a node while going around the cycle, where I runs from 1 till k minus 2, and we do a union of vi k minus 1 with v2 k. So that just means you have a cycle and then you go through the cycle, but then you skip every time a node. And if you ask me, that means that either you get a sub-cycle of less elements, or you get something that goes around twice, and then you still have everything. And then again, I don't think it's very important. It's okay. We introduce. Now I got around here and then I gave up because I got tired. But on the other hand, if we do all of this, then we apparently are ready to read the paper, because then we have read the definition of all the notations that I use. We introduce some basic concepts from polyhedral theory needed in this sequel. See Schrijver 1986 for a comprehensive treatment of this subject. As, I think this sounds again a lot more difficult than it really is. Polyhedral is probably just a visualization of the graph in a multi-dimensional space. So if you have, say, I'm not even sure what polyhedral is, but I assume that it is like so you have A, and then we have AB, and then we have A, B, C. Now I want to connect those two. And then you can think of the D, you can put a D on top of that, and then you get the yeah, tetraeder. How is that in English? A tetrahedron. So this is a tetrahedron where you have simply 4 points, which are each on equal distance to all of the others. And you can think of, I'm not sure if how do they call that? Polyhedral, if that has equal distances. Let's just look up polyhedral. So apparently polyhedral is not complete, but I don't think it means anything else than just visualizing the stuff in some kind of space. I wouldn't know why not a multi-dimensional space. So if you just visualize the graph as so we have a graph of 3 points, you can visualize it as a triangle. If you have a complete graph of 4 points, you could visualize it as the edge, the corners of a tetrahedron. And if you have even W's or subgraphs or cliques of more points, let's say even 4, you could visualize them in a 4-dimensional space where they are just all at equal distance at each other and have a nice line between all of them, which is what you want. The clique means that you have an edge between every pair. And then they're going to partition that thing by cutting it. So you imagine you have a multi-dimensional I don't know, tetrahedron, as it were, and then you just cut it with a plane. You cut enough edges such that it falls apart into 2 complete, tetrahedrons. For example, in this case, this I only have 2 dimensions, but this was the 1-dimensional case, this is the 2-dimensional case, this is the 3-dimensional case. So if you would cut this thing over this line here, then you would get, surprisingly, or not surprisingly, then you get lower dimensional tetrahedrons. What was it? God's sake, what was it? Tetrahedron. So you get, if you cut it like this, you get a 1-dimensional tetrahedron and a 2-dimensional tetrahedron. And obviously, if you have an actual tetrahedron, so there's a D above it here, and you cut it with a plane, then you could get a triangle and a separate D, or you could cut 2 edges and then you would have 2 of those. You only end up with A, B and C, D, depending on how you cut it. Now apparently there was a theory about that, theory of polyhedral theory, and they're going to use that. That's how I read it. Our universe will be the vector space RE. So yeah, that's a multidimensional thing, and not just like I thought, but multidimensional for each edge even. Right. E is the edge set of the graph. So they already put this one thing has 3 edges. Well, I would say I need only 2 dimensions for 3 vertices. So that would be the dimension of v minus 1. And they want to talk about edges. So in the case of if you add a d, then I would say I need 3 dimensions to show a tetrahedron. I believe that I've got it again. Yeah, tetrahedron. But apparently, I mean, tetrahedron has 6 edges. Apparently they won't immediately put that thing in a 6-dimensional space. I guess it doesn't really matter. Let's continue reading. They have a vector space where they have R values for each edge. Maybe you should forget the visualization and just go straight for this. Each pair has a value. So let's say it is a bit much. Let's go to 4. VI additions 4 What the heck? Why would that fail? Occasionally look at the chat. Timothy asks. No. Tourism Botakanov asks. Let's read the chat. Okay, now suddenly we're back at debugging the program. Why would it go wrong? That's why. So in the case of 4 edges, we have, 4 nodes, we have the edge AB, and we have the edge AC, with the value of -1, and we have the edge AD with the value is -1, and we have the edge of BC with the 5, and we have the edge of BD value 100, and then we have CD value -100. Yeah, so this is just this vertical, and then those, and then that. So it isn't it the order here. So we have 6 edges, and then you can look at this as a vector. This is a 6-dimensional vector. We have a 6-dimensional vector here with 6 values. Okay. So the universe is the vector space R number of edges. If F is a subset of E, then CF is element of RE. Denote the incidence vector of F. To think about this, do we take the subset of all the edges? Then CF, what the hell is XC? Maybe per definition then here. CF then denotes the incidence vector of F. That is XEF is 1 if E is element of F, and XEF is 0 otherwise. Oh, like that. Okay, so for example, if we have the group, let's say ACD, so ACD has AC, AD, and CD as edges. Then this is our F, it's a subset of all the edges. And then the CF, and I don't have a C on my keyboard, so let's call this CF, capital F, yep. Is then, well, AB is not in it, so that's going to be 0. AC is in it, AD is in it, and CD is in it. And the others are not in it. So they define a subset of edges by this vector. We denote the convex hull of a set S subset of RE by conv S. What does that mean? Okay, well, convex hull is something that encloses stuff without having a dent. So it's always what is it called? spherical, I guess. So this is spherical, and then the other way around is like this. Okay, so if there is a dent in it, then you have something like this instead of like this. So convex means that there's no dent in it, but it's hard to imagine that in a multi-dimensional space, I guess. So, but yeah, you could have a few points in our space and then define a convex hull around it. A polytope P is the convex hull of finitely many points, or equivalently a bounded set that is the intersection of finitely many half spaces. Really? And then you think they're explaining things to make it clear. I think I have to look up what the polytope is. It doesn't make it very clear. I would say that polytope is a polyhedron that is convex. That wouldn't make the most sense. But then again, here's a book, and that is not true. You have dents in it here, so I don't know. Polytope versus polyhedron. That's what it says here. This terminology is typically confined to polytopes and polyhedra that are convex. Convex polyhedron is the intersection of a finite number of half spaces. Ah, now I get the whole sentence as well. So just imagine that you have a big block of cheese, and you have a sharp knife, and you can only cut in half planes. You cannot make round cuts. You can only cut something that is flat. Okay, that's just flat like a plane. You can cut whatever you want, but you never end up with a piece of cheese that has dents in it. So if you make in a multi-dimensional space intersections of half spaces, so you cannot talk about the intersection that is made of a cut in a plane, because there's more than one dimension, I think. But you can talk about half spaces. So that's, you make a cut and you throw away half of the space, and then the point where it got cut off is flat, in a sense. Then in the same way you end up with a convex polytope, apparently. An inequality ATX less than or equal alpha is valid with respect to P if P is subset of all x's for which xtx is less than or equal alpha. Okay, they managed to make a new sentence that is very difficult. I think that they probably mean with x a vector in this e-dimensional space, and I think that AT is then one of those half-plane cuts. But I must say, I am just guessing here. Does this make sense? Probably. I don't know for sure, but let's assume that this is true. Then A is some matrix, and maybe T means a transpose of the matrix, but whatever, it's still a matrix, aka an operation, and then a linear operation at that, and then what would be equal to alpha, then you have something linear, so that would mean that this is x is on the surface of an infinite half space. I mean, the less than means that x is on one side, So you cut your whole space in two. Then, because it is less than or equal, you have a half space. And if it would be larger than alpha, then you have access on the other side. Yeah, so I'm going to read this as something that defines one of those infinitely large half spaces. Then it says the inequality, something that defines a half space, is valid with respect to P. And P stands for polytope, so that's still a convex hull polytope. Is if P falls within that half space. So all axes that fulfill this. So we have this. We have a convex. We have a convex polytope in our multidimensional space. We make a random cut, and if then we do not cut P into pieces, but we miss it, and then all of P is on one side of that cut, and that's when I call it valid. If ATX, so if that cut is valid with respect to some polytope P, then they define FA. Well, already defined F, so this is more the definition of what the A means here. As all axis element of P, for which the axes are actually on the border of the half space. Is the phase induced by the ATX less or equal alpha. So I guess F is now a phase of the polytope, and then the phase is defined by A in a way that actually it is related to one of those cuts. Thing that I don't understand here is that you could completely miss the polytope. And then I wouldn't call it a face. Yeah, I'm not really getting that. I mean, this looks like they think that this is not empty, aka they go the other way around. They're just cutting the cheese, and then this is one of the cuts. Sorry, yeah. The A index here defines the cut. And then F is then the face. The face of the cheese that you just cut off. But the way they formulate it is I think incorrect. So they start from the other side. But okay, I think that's what they try to do. Or they call it a facet. So a facet of P is a face of P that is contained in no other face of P different from P. I cannot wrap around my head around it. What is that saying? I have no idea what they're saying here. I mean, P is convex, so let's say if you would have something with dents in it, then you could make a cut and then get two faces that are in the same plane, but not connected. But that's not possible for a convex polytope. So why would I even mention this? Anyway, equivalently, a facet F of P is a non-empty face with the dimension of F is the dimension of P minus 1. The dimension S denotes the dimension of a set S, e.a. the maximum number of finally independent points in S minus 1. That is just multidimensional speak. But if you, as long as you keep it in 3 dimensions while you imagine this, then they're just saying that the facet is 2 dimensions. So you have a 3-dimensional cheese. Minus 1 is 2. So the sides that you cut are 2-dimensional. But yeah, if you have higher dimensions, that you get. So in our case, we had 6-dimensional space, like here. So if you make a cut here, you get a 5-dimensional surface of a facet. The polytope is a subset of the whole space. That's usually the case. Has a dimension e. Sorry, has a dimension the size of number of edges. So it's a not flat. It just really needs the whole space. Then every facet of P is induced by a valid inequality that is unique up to multiplication by positive constant. Okay, I missed that part of that the dimension could be less. Maybe that's what I talked about before. Let me think. Yeah, I'm afraid I cannot imagine what I mean in that case, or if that is related. If FA, oh sorry, if ATX is less or equal alpha is valid for P, and FA is defined as intersection between P and the surface of the thing. Well, they already did that. Looks like the same definition to me. I mean, if you leave out the element of P here, then you get the same thing as this. So that would be all the axes on the surface of this cut. But you must restrict yourself to all the axes that are element of P. If you do it the other way around, you just get all the axes on the surface of the cut. And then you make an intersection with the cheese, then you get the surface of the cheese. Yes, that's exactly the same thing. So this is valid for P, and this is one side of the cheese is a facet of P. We say that the cut is facet defining. Now, this is more like it. Though I was missing that here. So in this case I could say the cut could completely miss the cheese, and then what were you talking about? But in this case they say the cut is not missing the cheese, so it's face defining. Okay. If X is element of... Now finally they say that X is an element for E. We missed that in everything that before that was. And F is a subset of E. Then the sum of all E element of F of XE is abbreviated by X of F. I think this is the weight, the sum of our weights. So x is a vector. We had that here. This is our vector here. And this is E, the elements of it. And then in the case of F, we just have these three. So the things that are marked with a 1 here. And then they say that the sum over all, I'm going to read this E as indeed edge. So the sum of all edges, element in F, so that would be the sum over AC, AD and CD. Yeah, used as the coordinate of X. So that would be the sum of -1, -1 and -100. So -102 would be that sum for F, for the given F. And they abbreviate that by X of F. Now, I'm confused again what X means here, but seems that X stands for the vector of all the weights, right? So literally this thing is X then. If that's true, then I have to start over reading again here, because I imagined this X to be an arbitrary vector. But well, I guess I got to get the gist of it. The final sentence. S between vertical bars denotes cardinality of the set S. Means the number of elements in it. Kind of forgot what they mean with S. S is a node set. Or rather arbitrary node set, I guess. Literally some subset of the graph. And for alpha element of R, so alpha is a real number. The vertical bars with little horizontal lines, which is usually called floor. Denotes the largest integer not larger than alpha. Yep, so that's just simply the floor of alpha. Poo-poo. What the hell does this mean? B-binary relations. Well, unknown user as an extension of files, yeah. I mean, you can use anything, but it is easier to use something that is recognized by tools. Most tools would recognize them, I think. There's even a capital C. Nobody's using that. Like 90% of the people use CPP. And then the rest uses CXX, I guess. Or maybe CC. C++ I never see as extension. Extremely unlikely. Well, you didn't talk about file extensions. So I'm just guessing. But yeah, then in terms of phonetics, the PP stands for plus plus, and the X's are the pluses rotated 45 degrees, and the C is pronounced the same as capital C, so they made it a lowercase c. And then the CC is dubious, I guess, maybe more file extension related than anything else. Yeah, okay, I do get tired, but then I get the urge to skip ahead. That's probably not the best thing with a paper like this. the biggest problem here is that I'm not motivated or not convinced that it's going to be useful to read this. Okay, what I get out of it is that I think that let me think how to formulate this. I'm not happy that I moved to binary relationships. That's not what I want. I did get a new idea though. What I could do is even 16 finish is currently very fast, right? aka immediately. I really need to have a brute force solution first. I want to know if these things are correct or not. If this is correct and it's immediate, then well, then I'm done, right? I need a way to compare my result with the actual solution. I'm from the Netherlands, Arthur. Yep, I think I'm going to write something that finds a perfect solution first. And now we can continue with our adventure. Plus, I'm just totally seriously interested in what happens if I use 32. Just, I mean, at some point it has become slow. Seriously did not code it in a way that it works. Relocation, what the fuck is this? Oh, that's interesting. Nobody understands this. Oh, possible scores. Yeah, we have got too many edges, so I cannot store this. Yeah, 32 is way too big. Possible scores is oh no. Well, somewhere I have a max score index. I think this becomes too big. Max score index is get pair and get long. That's probably just going to be around the size of a 2 to the power 32 array. That doesn't fit in the BSS anymore. I could try to put it on the heap. Let's see if that solves it. I have loads of RAM. So let's make G-scores. It's not even a cons expression, so why not? Let's make this a pointer. An array. Well, let's make it a vector then. Max score index plus 1. That should allocate it on the heap. For the rest it's basically the same thing. It's still slightly too big. Okay, let's try to minimize this. 16 did work, right? It's not just that I change this type that something goes wrong. I mean, extremely unlikely. I think I'm on the right track with this allocation size. So that simply still works. And then we're going to increase it in chunks. Well, not 32, then what about 24? There's another problem. I have 24 characters. I do not have 32 characters in my alphabet. But I don't. Do we get past printable characters? Well, who cares? It doesn't really matter actually. Yeah, that seems to be mostly concerned with the random number generation or something. Because once it starts printing, it's bang finished. Again, pretty fast. I want slightly more infinite things. Shall I first try 30? And what do you mean with this? Skyrocket. Okay, well, clearly the algorithm is fast enough, I think, if it works, and probably doesn't. The idea that I had is that my next algorithm So we try algorithm 0 and then 1 and then so on until they block. And then I have switched to algorithm 2, which is going to run algorithm 0 and 1 alternating on each of the subgroups. So I'm gonna split this one up. No, that's nonsensical, isn't it? If that was possible, it would do it anyway. What I want to do is split it up. So I need some kind of relaxation so that it is able to split it up. Then the score will go down. But we find, say, the things that want to be together the most. So I could say, how can I split this up into 2 groups such that the total score goes down the least? Or could even make a whole list of it. Split it up in 2, split it up in 3, split it up in 4, etc. All the way down. So make a whole list of splitting this up into multiple groups such that the score goes down the least. And then we run the algorithm that tries to move one of those things to another group, keeping the rest in here. Even more powerful would be to move 2 of them, but okay, that's the next step. I could build that into this algorithm already if I simply allowed for forming groups that are interconnected. So if I cut this thing in 2, but I still count the edges from here to there. And then have a kind of a sub score for each group separately. Yeah, that's an interesting idea. So a group of 1 cannot be split. A group of 2 can be split in 2, and then I still count it as I still count the edges from T till square bracket open, and each alone doesn't give anything, so that's not interesting, right? But if, for example, I could split this one into B of J and OP without changing the score, because those 2 then would still counting it. But I look at B of G as a group and see what that gives me as a score, and I look at OP as a group and see what that gives me as a score. And then you automatically get it wants to split it up then, because the more groups it has, the higher the score, because it's not losing anything by splitting it up. So then I get subgroups that kind of belong together, and then I'm going to try to move those subgroups to other groups, at which point we lose the connection with the rest. But yeah, I'm thinking about this paper. I think what I try to do is they have this multi-dimensional space equal to the number of edges, and then they try to move their cuts in a way that basically do the same thing as what I do. Yeah, I do not understand it well enough to really have a grasp on what they're doing, I have to say. It would take me probably up to 2 weeks just to understand this and write some program to play with the idea. And I really don't want to. It just doesn't feel like it's worth my time. So most of it is just results. Application. This is mostly text. So the hardest part that I would still have to read in, I guess, is 3 and 2. Yep. Just read 1 now. Yeah, well, we had absolutely nothing else to do, huh? But we were writing a Vulkan engine. I just got sidetracked, I think. I'm too much a perfectionist. We already know that there's no perfect solution. And still I'm pounding on it. It's an NP incomplete problem. I think I'm going to stop the stream and then come back to it later. After I did eat dinner and stuff like that. I think that's a good idea. So yeah, see you in maybe in a couple of hours. If you average watch time would be, let me see. This is really funny. Stream is healthy. Analytics. The average view duration is 1.5 minutes. How can I have 28 viewers? For a long time I was over 50 viewers, and then it dropped when I started the heavy math to 25 viewers. And all that time, 5 hours long or something. No, 3 hours long. And they, on average, they watch 1.5 minutes. I totally do not have the feeling that people come here and then immediately leave. If that would be the case continuously, then how would I have 25 viewers continuously? Is that really every minute everyone is recycled? So in 2 minutes everyone that's listening now is left, and then in the meantime I got 25 new viewers. YouTube is really working hard to tell people to go to my channel, it seems. But hey, even though we have only an average view duration of 1 minute and 27 seconds, I have 152 likes. So you would say that you don't like it if you leave within 1.5 minutes. No, I think the thing is that only 10 or so, maybe 15 people for some reason want to keep watching, which I still cannot wrap my head around, but I'm happy with that, of course. You are my friends. And then we have 6,200 people that joined this channel and left again pretty quickly. And that made the average view duration pretty low. Okay, well, anyway, I'll see you next time. Hey Ratin, thank you for moderating.